61A, Lecture 31, Q&A. So the question is, if you already have some procedure that takes X and Y, like adds them together, and you then want to convert this into a procedure that takes only one argument and holds the other one constant, could you do that by saying lambda x is a procedure which takes X and calls G on whatever that X is and 3. And here we have indeed created a procedure. Now, we either need to call it or give it a name. I think we should just give it a name. That seems easier. So now we have a 1 argument procedure that adds 3 to things. So if I call f on 7, then I get 10. So like the longer version of this would be if instead of setting this equal to 3, we set it equal to some y. And where's that y? Well, it's coming in here. Now we have kind of a curried version of G. So if we call this H, H is the kind of thing that you have to call in order to get a procedure. And then when you call that procedure, then you're finally adding 3 and 7 together. I think they're equivalent.
Yeah, those are the same thing. Just one more level of indirection for you, yeah.
The next question was what validate procedure does in the scheme project. It's a Python function. So here's what it does, is it you call it and it raises an error or it returns none. So you can never really do anything with the result of validate procedure, so you wouldn't use it inside an if. You just call it to make sure that the argument that you have is really a procedure as opposed to some other weird list. Yeah, good question. So the question's about this Data 8 module called datascience, which we built for the course here, and whether it's really just running SQL under the hood. It's not, but we borrowed the names for a reason. I think that these standard operations that you perform on a table, like joining, or I guess we'll do joins on Monday, but like the where to filter it and select in order to get particular columns, they're standard operations, and because SQL is the most popular programming language in the world, those are the conventional names for them at this point. I mean, sometimes maybe instead of calling it where, you might call it filter, but I think the SQL names are kind of the most common names that people have for these different table operations. So you see them showing up in lots of different modules, not just the Data 8 one, as the description of how you manipulate tables using another programming language. And this notion of declarative programming and manipulating tables is not specific to SQL. Like it shows up in lots of different programming languages. Oftentimes what is happening is that you're just running, you're like converting Python into SQL and then running that SQL. That's actually not what's happening in Data 8. You're just kind of running Python code. But we set it up this way so that you could convert it to instead run SQL if you wanted to. In fact, we had plans to do that for a while, but we never really got around to it. Yeah, good question.
Yeah.
So the question is, if you have a list of values, like you have, my values are 1 and 2. And what you'd really like to do is add 1, 2. But instead of passing in each of these, we want to say, I want to add all the stuff that's in the list of values. Well, this won't work because plus expects 2 arguments, and here we're passing only 1. It expects numbers. Here we're passing in a list. So what do? And the answer is that there's a built-in procedure called apply, which says apply plus to these values, and then it basically constructs that and evaluates it. Yeah, so just to like follow up on this example that we had before with apply, let's say we wanted to define sum, which takes a list of, let's call them params. And what does it do? Well, we want to like add and then have like all the params in here. Well, we would just write apply plus to the params. And the next question now I have a procedure. What do the terms linear and quadratic a list of values that were used in the lecture get added together?
So I don't think we're doing a lot of runtime complexity. So we're not going to go into too much detail here, but here's the basic idea. When you measure runtime complexity, you measure it as a function of the size of the input. Yeah. So how many numbers do I want to add? Okay, that's the size of the input. I want to sort a list. How many elements are in the list? I want to select something from a table. How many rows are in the table? Right. So the size of the data is how we specify the complexity. If something is linear in the size of the input, it means that every time you add an element to the size of your data, your complexity increases linearly proportional to that. So if I double the size of the input, my runtime is double. If I quadruple the size of the input, my runtime is quadruple. Right. So if you think about, imagine a plot that has the size of your data on the horizontal axis and the run and how long it takes to run on the vertical axis. Linear literally means it's linear, right? It grows linearly with that. That's good. That's really nice. It means that things don't get out of control. It's not great, but it's good. Logarithmic means that it does this. It slows down as the data gets larger. That's really, really nice. Yeah. Quadratic is the opposite. It means that if I double the size of the data, my complexity increases by a factor of 4 because it's 2 squared. So the quadratic, think about sort of a parabola. As you increase n, your complexity starts going faster and faster and faster. Really bad is exponential. It goes with 2 to the power as opposed to n to the power. So there's sort of a couple of categories of runtime complexity. There's constant time. That's amazing. No matter how big the database is, it takes constant time. There's logarithmic time, very, very slow growth, very good. Linear, good. Polynomial, which means n squared, n cubed, n to the fourth, n to the fifth, okay, but it's going to be a problem for large databases. And then exponential, which is a disaster because, or factorial, which is a disaster because as soon as n gets to even a relatively small number, the whole thing breaks down. So those are sort of the rough categories. And that's what John meant when he was referring to quadratic versus linear.
And I think maybe the reason that surprised you is that we made the lecture on efficiency optional. So if you missed that along the way, that's fine this semester. You'll do lots of it in 61B if you take that class. But if you want like a 45-minute version of what Hani just said, which you don't need, but if you really want it, then there's that efficiency lecture sitting there in the schedule from like sometime before midterm 2. The next question is, what is this thing called NoSQL, and how does it relate to SQL?
I'll give you my spiel on this, and I'm curious what John thinks. So SQL is an actual database program, but it's also been used to refer to a class of types of databases. So there are databases that are called NoSQL, which just means they're not using SQL. And then within SQL, there's MySQL, there's SQL, there's SQLite. Those are all essentially variants on the same basic underlying database management system with some bells and whistles either included or excluded. I think we're just learning SQL. You don't have to worry about which specific version of it is.
Yeah, and the funny thing about NoSQL databases is that oftentimes they still use something that looks almost exactly like SQL in order to access them.
Yeah.
But they don't come with the same guarantees about what happens when multiple different programs access the database at the same time. That's basically the main story about NoSQL, is that in order to make sure that nothing breaks when multiple different computers are all accessing the database at the same time, you have to slow some of those processes down. Like some stuff has to wait for other stuff in order to make sure that like nothing gets confused along the way. And NoSQL tends to relax that in various ways. And so the nice thing is that if you relax these kinds of constraints, then you could have applications grow up to a much larger scale and still be fast, but the downside is it might be the case that if you check your email, it doesn't show you all the emails that have been delivered yet because of some like weird synchronization issue, and you'll see it eventually, but you might not see it right away. So it's a great topic for taking a database course or a data management course. There's a new one being developed here that's just being piloted this next semester. We also have a standard database course that focuses more on SQL, but doesn't talk too much, I think, about the NoSQL variants. But it's more branding than anything else. They called it NoSQL to try to make sure that it was distinct in people's minds. But it's not like what you learn about SQL doesn't apply. In fact, all the operations that you learn in SQL are basically the same there as well.
And I'm not a database expert. My understanding is that SQL does start to break down for very, very large databases because of the guarantees. And you do need to move to something that is not as strict. If you're going to have these Google size, Facebook size, massive databases with terabytes and petabytes, it just you have to do something a little bit different to really get them scaled. I don't know where things start breaking down specifically, but really, really large databases tend not to be SQL. Isn't that right, John?
Yeah, but people have also figured out how to get quite large databases to run in like a standard SQL-based database. Like, last time I checked, Uber's data was still running through SQL, and like they have a whole lot of cars driving around. And so you'd think that was maybe too big, but in fact, it's not, because it's nicely partitioned into different cities. And so so it turns out that like they can manage their data using sort of a more standard classical method. Anyway, it's the right thing to do is learn SQL well, and then learn these variants once you kind of know the core that everybody else knows.
Yeah, I think that's exactly right.
The next question was, is SQL a fast language or is it slow? SQL is a fast language in the following sense. You can write a query that in principle appears to have to do a lot of work. And the database engine will figure out the fastest way to execute that. And it will execute it quickly in the sense that, most database engines are written in some programming language that's supposed to run very fast, like C or something like that. And so you usually don't pay any kind of time cost for using SQL in a big application, because that's like a fast way to do it. It's not fast in the following two ways. One, if you're actually like computing something inside your SQL query, like you're doing tons of arithmetic, well, that's usually a bad idea. It's a language that's meant to express operations over whole tables that doesn't involve like going through each line and keeping a running total. But like, if you're ever like trying to write something procedurally in SQL, sometimes you can't even do it. And if you did do it, it'd probably be slow. So, you have to kind of stick with the right model, which is, take the table, process all the rows, aggregate them. We'll do that next Wednesday. And then now you've built your new table. So the other way it's slow is that if it's the case that many different computers are all trying to access the same database at once, it tries to ensure these various consistency properties that mean that some of them have to wait for other ones to finish. So basically, like, you can't have two programs writing to the same row at the same time. You can't even have one writing to the row and another one reading to the row. And so in that sense, it can be slower than some NoSQL variant. But that, that usually doesn't apply, because usually you don't have a program where like thousands of different computers are all accessing the database at the same time. But sometimes you do. And there's a third way it's slow, which is that if you don't set up your database right, then it can be much slower than it needs to be. So there's a whole topic we won't get to in this course about indexing the data in order to make sure that common queries are fast. A lot of this actually just happens automatically in a modern database management system, so you don't always have to think about it much, but sometimes you do. And in that case, like, there is performance optimization that happens in databases where you have to kind of look and see, oh, why is it slow? But then usually you can make it faster as opposed to being stuck with it being slow.
And NoSQL databases have the same thing. You have to think carefully when you're building the database of how to make them efficient. So they have the same indexing limitations as well.
But there's nothing about SQL that's kind of inherently slow in the way that Python might be, where like the basic operation could be done faster by some other programming language. The next question is, why does SQL conventionally capitalize its keywords like select and where, and how come we don't do that in 61A? I'll let you listen to the whole answer, but we don't do it in 61A basically because I forgot. But, the more recently created examples do use all caps for select and where, and it is a common convention, so you might as well pick it up.
I don't know that, John, do you know the history of this? It's true that all SQL commands are always caps. I don't know the history of that. It just may just be a convention, but maybe there's another story behind it.
Yeah, I don't know either. I mean, people were writing SQL queries long before there were text editors that automatically highlighted the syntax for you and stuff like that. So the capitalization scheme is a nice way to distinguish between, what's part of the language and what's specific to your database, because you're just interleaving names like select with names like person, where person describes some column in the table. And so this capitalization scheme kind of keeps those distinct, which I think is good. SQL was designed to be a programming language that not just programmers would write, but it was meant to be accessible to, analysts who maybe didn't know that much about programming, but needed to access the database. So I think the history of some of these design choices was motivated by making it appealing to a general audience. I guess they succeeded in the sense that a lot of people use this programming language, but it's a little funny in its all caps character. And in this class, we don't always capitalize everything in my demos because yeah, I don't know. I just didn't think about this convention very much when I started building these demos. But I think, capitalizing the keywords like select and where is usually a good convention. You might as well do that.
Yeah. My recollection, John, is back in the days when we wrote Fortran code, there was also a convention of capitalizing. I wonder if it came from there.
Yeah, they're kind of from the same vintage, I guess.
Yeah, they're about the same vintage too. By the way, I use all caps whenever I have constants in my code, Python code, MATLAB code, C code, and so you will see that kind of capitalization used in classic imperative programming to sort of have things stand out. It's not functions, but it's things like constants, for example, that are often done with all caps.
Yeah, so the question is, how could you have a row but not fill in all the values? There is a way to have missing values in a SQL table, but it makes your life a lot more complicated if you're ever missing values. So, I mean, effectively, you can put a none value in there. And how do you do it? I don't actually remember at the moment, but certainly it's possible to build an empty row and then fill it in later. We'll talk about the commands for changing a row next Friday in the optional lecture, where we talk, so far we never changed any rows, right? We just had a table and then we built a new table and we built a new table. But once you built a table, all the values were there and they never changed. But it is possible to perform mutation operations on a database table where you basically say oh, this person's name changed from Stephen to Steve, and you can make that edit. And there's a command called update, which does that. So it is certainly possible to fill in stuff after you create it. And it's also possible to have empty cells, basically none values. But
John's right.
It's a good idea to avoid it.
This is one thing with SQL tables generally is they have uniform columns. You can't just sort of pick and choose. Now, there's other databases where you can have variable number of columns per row and varied data types. And SQL is a very disciplined language, which allows it to sort of be efficient. So I think it's at its best when there is data and it's the same format. And so I tend to think of that as I knew that there was a none option, but I don't know how to do it either. But I don't think I've ever done that when I've done SQL. It's always when I'm using a database like that, it is fully populated.
Yeah, but sometimes you just you don't know someone's address, so you need a blank in there, and that does exist. But we won't talk about it in this course. The next question was about courses. Does it make sense to take 61B and 16A in the same semester?
John has more experiences than I do, but let me just share a few thoughts. One is I think part of this depends on your comfort with math. So if you feel really comfortable with discrete math and linear algebra and things like that, maybe it's okay. I think it's a lot. I'm told John will know more about this, that 61B is a lot of class. And I think 16A is also a fair amount of class. So I think part of it sort of depends on your comfort level with the underlying material. And you can go look at the syllabus now and see, how foreign it all seems. But I'm curious what John recommends.
Yeah, so the combination of 16A and 61B is reasonable in the sense that I wouldn't say no student should ever do this. Like it's a reasonable combination, but 61B tends to be quite time intensive. 16A is always at least somewhat time intensive. There's a lot to learn in that course, but also depending on students' math background, it can be quite intense just because it's often their kind of first college math class. And then again, for other students, they've already taken a college math class. They kind of know the rhythm, or yeah, or if you had kind of strong preparation in high school, then it can be smoother. So one thing I would say is that finding the pace that's right for you is much more important than doing what's good for like the average student. So if it turns out, and this isn't really particularly advice for you, this is just kind of general advice. If for any student that discovers like, oh, it's better to kind of take one technical course a term instead of two, or only one programming course and a math course, but you kind of don't want the math course to be too intense if the programming course is intense, or whatever it is, that gives you kind of a comfortable way to understand all the material, not fall behind, kind of master things as you go, even if they're brand new. That's the way to do college. I think cramming in a bunch of stuff in a semester is almost never a good idea, unless, if you're familiar with all of it a little bit, and so you can handle a lot and actually like learn the material, then it's fine to take more courses. But taking so many courses that you can't keep up is just not a good idea ever.
Yeah, but I want to emphasize something here, and then there's a question in the chat which we'll respond to, is there's depth and breadth in your education. And it's easy to get breadth. Just, take a bunch of courses, but you really also you want to think a little bit about the quality of this course. It's not about just getting through it. It's not about just getting the grade. It really is about understanding the stuff. And particularly early on in your academic career, where everything builds on previous courses. These courses don't stand alone. You're building a scaffolding that you eventually have to climb up against. And so it's really, really important to make sure that it's high quality, light touch at the beginning, in my opinion. Is SQL databases used internally in programs? What comes to mind is Lightroom photo catalog that keeps track of thousands of images and several gigabyte of data. I don't know about Lightroom in particular, but I imagine the answer is yes. The SQL is used internally to keep track of these types of databases. John probably knows more about this.
Yeah, the particular database management system we're using in this course, SQLite, was designed to be embedded in the sense that it's part of a larger application that's not necessarily written in all SQL, but does do data storage using the SQL approach. And it all gets stored in a file. So, instead of a programmer having to invent their own file format for storing all these records about, photos and when they were taken and whatever, you just use SQLite. And Python, we'll see next Friday, has a built-in SQLite interface, which means that you can, within a Python program, send data to your SQLite database and make queries and get the data back out. So, and this is very common. It's not the only way. Sometimes there's a good reason to invent your own kind of data management approach. Usually, if what you're doing with the data is so simple that all you have to do is just like write down a big column and then like read that column, then you're not going to use SQL. But as soon as you have multiple tables that might reference each other, then there's kind of no reason to invent your own way of doing this. You just embed some existing SQL-based system like SQLite, or there's other options too. Great question. So like, what are the constraints on what values you can put within a column in SQL? Here, there is actually quite a bit of variety when you look at different database management systems. And SQLite's kind of an outlier in that it lets you sort of not specify too much about what the data format is in advance. Whereas a lot of popular database management systems require you to not only say like, this is going to be a string, but to decide on the maximum length of the string that you'll ever put in there. And if you can do this in advance, if you know like, oh, this is going to be a, 14 character string because you know it's someone's driver's license number and they're never longer than that, then that can add to the efficiency of the system. But it leads to problems if all of a sudden like, some state decides they're going to use even longer driver's license codes and they don't fit in your slot anymore. So there's no one answer to this question of like, what are the constraints? It will depend on the database management system. SQLite, you can learn about the constraints there. I think strings can have arbitrary length, and so there's nothing kind of really special about them. But you have to kind of relearn this for whatever other database management system you're using, whether it's MySQL or Postgres or something like that you run into in the future.
Yeah, I think if I recall, John, SQL has a very strict, you have to define everything, like how big the integer is going to be, how big the strings are going to be. Everything has to be defined up front.
Yeah, I think both MySQL and Postgres do this, and anything that's really designed for very large databases, data sets that are going to be accessed by multiple programs, and this is kind of the central hub for a whole service, tends to make you decide a lot about your data in advance.
Yeah.
Whereas SQLite's sort of designed for moderate size stuff, that can fit on one computer pretty easily. And there they give you some more flexibility.
Yeah, that's right.
A good question. So is it standard to like create an empty grid and then fill in the values, or do you always sort of build it at once? I'd say what's common is that you often create a table with no rows, but a particular set of columns, like you've come up with their names and you know how many columns there are. And then you add the rows one by one, but when you add a row, you add it with the data in it. I think that's the most common way that tables are built. That's not what we did today in lecture. Instead, we kind of built the columns and the rows all at once. But we will do this on Friday. I'll show you how to kind of build a table more incrementally. And as far as like building a grid and then adding stuff later, I think that's relatively unusual. Typically, you don't know how many rows there will be in advance because it depends what happens in the course of the program. And so tables grow over time. You add more rows because you add a row every time some new user shows up or something like that. And so the columns in advance, but the rows get added incrementally. The next two questions were logistical, so I'll just answer them here. One was, can you work alone or do you have to work with a partner? No, you can work alone. And if you're working alone and then you find a partner, you could merge your work with them. That's okay. The second was, are there checkpoints for the challenge version? And the answer is no, there are no checkpoints for the challenge version. You just have to complete the whole thing by the deadline or get an early submission bonus point. And then I gave some opinions about the challenge version in general. Here we go. Just for everybody out there thinking about doing the challenge version, the regular version is plenty of work. You don't need to do the challenge version. In fact, maybe you do the regular version and then do the challenge version in your own time over winter break would be a more reasonable thing. So only if you're finding that the projects are just kind of too simple and too structured for you and you're tired of doing it that way, then maybe do the challenge version. But don't do it just because it's there. Yeah, good question. So it's like, is there any way to have a value in SQL be something that's kind of changing all the time or could be mutated by another program? I think the answer is no. I think the way these are set up is that they're just kind of static values in the table. Another program can go change those values. So it can like change, someone's name from, Henry to Hank or something like that. But But I don't think there's a way to have the values themselves be kind of mutable things that change over
Yeah,
time.
like on the fly, like every time you query a cell, it generates a random number. I don't think you can do that. Or salts a data by adding something. I don't think you can do that in SQL.
But what does often happen is that you'll have a table where each row is like a different version of the same thing.
Mm.
And you have a column for what version it is, and then you have a column for what the value is now. And every time you kind of make an update, your encryption key changes daily or something like that, then you'd add a new row to this thing, which says, oh, now the current value is whatever for this particular day. And so even without dynamic changes, you can get that kind of dynamic flavor just by kind of storing more data.
You can change a cell. You can change data in a table. That's fine. I mean, it's not like once you add a row, no, the data can't change. You can update that.
Right. But
I
the other thing you could do is instead of having age of a person be the row, you could have a row represent a person at a particular time.
Yeah.
And that means they have an age at that particular time, where one column stores the time. In 2006, I was 26. And then there's another row that says in 2007, I was 27. And so in that sense, you can keep track of changes over time just by more rows, by having your row not represent the thing that's changing, but instead what the thing was like at a particular snapshot in time, and have the time be one of the values in the rows.